Time, the one force we cannot see, yet it shapes every heartbeat, every sunrise, every death, and every dream. Humanity has always lived within its invisible cage, measuring it, fearing it, and chasing the impossible to escape it, from the ticking of ancient water clocks to the atomic precision of modern timepieces. We've learned to count time, but never to control it, and yet, hidden in the mathematics of the cosmos, in the folds of space and the quantum fog of particles, whispers of a shocking possibility emerge, that time might not flow in one direction at all. What if the future already exists, waiting for us to arrive? What if the past never truly dies, only fades into a different dimension of reality? Across centuries, philosophers dreamed it. Scientists pursued it, and storytellers warned us about its consequences. Tonight, the Wonder Lab invites you on a journey that will defy everything you thought you knew about existence. A journey through paradoxes, physics, and the very boundaries of reality itself. This is not fiction. This is science, unfolding at the edge of time. Since the dawn of consciousness, humankind has lived beneath the shadow of time. The first humans looked at the moving sun and felt something strange, a silent force that ruled their existence. Days became seasons, seasons became years, and soon time became the invisible god no one could see but everyone obeyed. In the deserts of Babylon, ancient astronomers carved the sky into a clock, tracking the dance of stars and moons to predict harvests and floods. In the heart of Egypt, priests aligned the pyramids to the solstice, believing that if they could master time, they could master eternity. But even as civilization grew, a question echoed through every age. What is time? Is it a river flowing endlessly forward, carrying us toward the unknown? Or is it a loop, repeating, folding, rewriting its own past? The Greek philosopher Heraclitus said, "You cannot step into the same river twice," believing time was a current, unstoppable. Yet centuries later, Einstein would whisper something far more dangerous. The river might not even be flowing at all. Our obsession grew darker. Kings and emperors built monuments to outlast time. Artists painted themselves into eternity. Alchemists sought elixirs of immortality, desperate to slow the ticking clock of their own decay. And in the modern age, the obsession only evolved. Today, we wear time on our wrists, measure it in microseconds, and schedule our entire lives around it. But despite all our control, time remains a mystery we cannot touch. Physicists can describe how time behaves, but no one can truly explain what it is. It bends. It stretches. It vanishes in the presence of speed and gravity. To a particle moving at the speed of light, time simply stops, and so the question grows louder. If time can be bent, can it also be broken? If it can be slowed, can it be reversed? Deep in the equations of relativity, in the heart of Einstein's theory, a crack appears, a place where time and space twist upon themselves. Within that twist lies the seed of the impossible. Time travel. To journey through time is to challenge the very structure of the universe. It means crossing boundaries nature has carefully hidden. But every time humanity meets a boundary, someone dares to cross it. From ancient dreamers to modern physicists, the quest to conquer time has never stopped. And the first true clue, the one that turned fantasy into scientific possibility, was discovered not in myth, but in mathematics. It began with a man sitting quietly in a Swiss patent office, sketching equations that would change reality forever. The year was 1905. A young man named Albert Einstein, working in a patent office in Bern, Switzerland, gazed out the window at a passing clock tower. He was not a professor, not a famous genius, just an ordinary clerk lost in extraordinary thoughts. As the world outside moved, he wondered, what would it be like To chase a beam of light? That single question shattered the walls of classical physics. For centuries, scientists believed time was absolute, that every second ticked equally for everyone, everywhere. But Einstein saw something different. He imagined two observers, one standing still, another moving close to the speed of light. The faster one moved, the slower their clock would tick. Not just the clock on their wrist, but the beating of their heart, the aging of their cells, the flow of their entire existence. Time itself, he realized, was relative. It could stretch, bend, and slow down depending on motion and gravity. The universe, he proposed, was not made of separate fabrics of space and time, but a single woven tapestry he called space-time. With that one concept, Einstein opened the door to the unthinkable. Time was not the unchanging river we believed it to be. It could curve, ripple, and, under the right conditions, even fold back upon itself. This was the first crack in the illusion of linear time. Soon, other minds joined the chase. Hermann Minkowski, Einstein's former teacher, expanded the idea, declaring that time and space are one entity. Every moment of your life, every breath, every step, every heartbeat exists as a coordinate in this vast cosmic fabric. Past, present, and future are not happening. They simply exist, side by side, like pages in a book already written. This concept, called the block universe theory, suggests something terrifying and beautiful. The future is already there, waiting. The past never vanished, and we are simply moving through the chapters one at a time. But if that's true, then time travel isn't about changing the past or reaching the future. It's about moving between the coordinates that already exist. The question, then, is not whether time travel is possible, but how to navigate space-time itself. Einstein's equations hinted at the path. Massive objects, stars, black holes, warp space-time. The stronger the gravity, the more time slows down. A clock near a black hole runs slower than a clock far away in open space. In theory, if one could orbit close enough to that gravitational well and then return, they would find centuries had passed elsewhere, while they had aged only a few hours. This is not science fiction. It's measurable physics. We have proven it with satellites, atomic clocks, and astronauts. Time, once thought to be universal, now bowed before gravity, and if gravity can stretch time, perhaps one day it could tear it open. For the first time in human history, the dream of time travel moved from myth to mathematics. But to turn theory into reality, science would need to go deeper, into the realms of the invisible, the quantum and the cosmic. The next frontier would belong not to dreamers, but to those who dared to confront the most mysterious objects in the universe, black holes. In the silent depths of space there exist places where the known laws of physics collapse, regions so dense, so powerful, that even light itself cannot escape. We call them black holes, but in truth they are not holes at all. They are scars, rips in the fabric of space-time, born from dying stars that crush themselves into near-infinite density. To approach a black hole is to approach the edge of reality. At its heart lies the singularity, a point where gravity becomes infinite and time ceases to behave as we understand it. Here, every second outside the event horizon could stretch into hours, days, or even centuries. If you were to orbit close enough to a black hole, you could watch the universe race ahead while your own time slowed to a crawl. You would witness distant galaxies evolve, stars burn out, and civilizations rise and vanish, all while only minutes passed for you. In a sense, black holes are natural time machines, one-way portals to the future. Yet beyond their immense pull lies an even stranger idea. Einstein's equations suggest that under extreme conditions, space-time could fold in such a way that two distant points might connect through a hidden passage, a wormhole. Imagine space-time as a sheet of paper, folded until two dots touch. The tunnel between them is a shortcut, a bridge between moments, between locations, perhaps even between eras. Could black holes and their theoretical twins, white holes, form the two mouths of such a bridge? If a black hole consumes matter, could a white hole on the other side eject it, as though the universe itself were breathing between 2 points in time? For decades, this concept haunted the greatest physicists, Einstein, Rosen, Wheeler, and Thorne. They called it the Einstein-Rosen bridge, the first mathematical doorway through time. But there's a catch. Nature guards her secrets well. These wormholes, if they exist, would collapse faster than light could pass through them. The tunnel would snap shut, crushed by gravity's own weight. To keep a wormhole open, something extraordinary would be needed, something that bends space-time the opposite way. Negative energy. A form of matter so exotic that it has never been seen, only predicted. If such matter exists, it could stabilize a wormhole long enough for information, or even a person, to pass through. The universe, then, would no longer be a vast distance measured in light years, but a folded labyrinth of corridors, each leading not only across space, but across time itself. Still, every equation raises another question. If you could travel through a wormhole and arrive before you left, what happens to causality, the sacred chain of cause and effect? Could you alter the past? Could you erase your own existence? These paradoxes threaten to unravel logic itself. And so, while black holes and wormholes opened theoretical paths through time, they also force scientists to confront something far deeper, the fragile nature of reality's timeline. The next step in the journey would lead not just through the cosmos, but into the smallest realms imaginable, the quantum world, where time may not even exist at all. If the vastness of black holes teaches us how time bends, the quantum world teaches us how time disappears. Deep beneath the structure of atoms, beneath the predictable orbits of electrons, there exists a place where reality trembles, a place where particles do not move in lines, but in probabilities. At this level, cause and effect blur into uncertainty. A particle can exist in many places at once. It can spin in two directions simultaneously. It can vanish, reappear, and even influence another particle instantly, across distances no force should cross. This is quantum entanglement, Einstein's spooky action at a distance. It defies logic. It mocks our sense of sequence, for if two particles remain linked across time and space, what does that say about the flow of time itself? Some physicists believe that at the quantum scale, time is not fundamental. It may not flow at all. Instead, what we experience as time could be a statistical illusion, a byproduct of how we observe change. To the universe, there is no past, no present, no future. There is only an infinite state of possibility, a quantum sea of nows. When we observe something, we collapse that sea into a single outcome, creating the illusion of a moment moving forward. But in truth, all those possibilities, all those timelines, still exist. The multiverse is not just a poetic theory. It is a mathematical consequence of quantum physics. Every time a particle chooses one path, other versions of reality branch away, forming endless alternate universes, where different decisions, different events, and different histories unfold. Somewhere another you made a different choice. Somewhere else another Earth spins under a slightly different sky. And all of it, every possibility, exists simultaneously in the quantum fabric. What we call the present is simply the slice we are aware of. To time travel in this view is not to move forward or backward, but to shift consciousness from one quantum layer of existence to another. Physicists like Hugh Everett, Carlo Rovelli, and Julian Barber have suggested that time might emerge only when matter interacts, that before interaction, time does not exist at all. Imagine a universe frozen in potential, waiting for observation to bring it to life. In that moment of awareness, in that act of observation, time is born. Could consciousness itself be the engine of time? Could it be that the universe experiences itself through us, moment by moment, giving birth to what we call the now? If so, then time travel may not require machines or wormholes, but understanding the nature of awareness itself. The boundaries between physics and philosophy begin to dissolve. In the equations of quantum mechanics, in the silence between measurements, we begin to glimpse something ancient and extraordinary. The possibility that time is not the ruler of reality, but its reflection. And if time is only an illusion, then the past is not gone, the future is not yet, and everything that ever was still is. What if every decision you ever made, and every one you didn't, still exists somewhere? What if every path you didn't take became real in another version of the universe, another version of you? This is not fantasy. It is the logical extension of quantum mechanics, the many worlds interpretation proposed by physicist Hugh Everett in 1957. According to Everett, when a quantum event occurs, say, a particle moves left or right, reality does not choose. It splits one universe for the particle that moves left, another for the particle that moves right. Two realities, both real, both coexisting. Now imagine that same principle applied not just to a particle, but to you, your choices, your moments, your life. Every time you make a decision, reality branches. One version of you walks away. Another stays. Another never existed at all. A multiverse, infinite in scope, endless in variation. In one, humanity has conquered space. In another, we never invented fire. In yet another, the earth was never born. Each world layered upon the next, like reflections in a cosmic mirror, unseen, yet profoundly connected. The question is no longer if these universes exist, but whether they can ever touch. Can information leak from one branch to another? Could a person, or a consciousness, ever slip between them? Some physicists believe yes. Experiments in quantum tunneling, interference, and entanglement hint that parallel realities may overlap in subtle ways, that energy, or even awareness, might bleed through the boundaries separating one universe from the next. And then something even more mysterious emerges. Déjà vu. That fleeting moment when you swear you've lived something before. The familiar echo of a conversation never had. A dream that predicts an event yet to come. What if déjà vu is not memory, but resonance? A brief synchronization between parallel versions of yourself. A signal crossing the multiverse. For in the grand design of existence, these worlds are not far away. They coexist in the same space, vibrating at different frequencies of reality. To move through time, then, may not mean traveling forward or backward, but shifting sideways, across dimensions where time itself unfolds differently. The self you are now is just one note in a symphony of infinite selves, playing in parallel, and if consciousness can tune itself through extreme states of awareness, through energy, through unknown laws, perhaps one could hear the echo of another timeline, or even step into it. Ancient mystics, shamans, and visionaries spoke of other worlds, of crossing veils, of remembering lives that were never lived. Modern science, in its equations and probabilities, is only now beginning to describe the same phenomenon, not through myth, but through mathematics. The multiverse, once dismissed as fantasy, is now one of the most active frontiers in theoretical physics. Each new discovery hints at a staggering truth. The universe we see is only a fraction of what exists, and if parallel realities are real, Then time travel is no longer a question of when, but which. Which universe will you choose to arrive in? Which version of you will look back from the other side? The future, it seems, does not lie ahead. It lies beside us, waiting to be found. Time travel sounds like a miracle until you realize it breaks everything we know about cause and effect, for in the logic of time, cause must come before consequence. But what happens when consequence comes first? When an action in the future creates or destroys the event that caused it? This is the nightmare of temporal paradoxes, the hidden traps waiting for anyone who dares to rewrite the past. The most famous of them all is the grandfather paradox. Imagine traveling back in time and preventing your grandfather from meeting your grandmother. You would never be born, which means you could never have traveled back in time, which means your grandfather would meet her after all. Logic collapses. Existence begins to loop upon itself, erasing cause, consequence, and meaning. But paradoxes are not just philosophical puzzles. They are the ultimate test of reality's stability. If time travel were possible, the universe would need a defense mechanism, a way to protect causality. Physicist Igor Novikov proposed one such safeguard: the self-consistency principle. According to Novikov, time may be flexible, but it is not chaotic. You can travel into the past, but you cannot change it in any way that would create a contradiction. The universe would self-correct, rearranging events to preserve the timeline. In other words, no matter what you do, the outcome would always lead back to the present that made it possible. It's a closed loop, fate disguised as freedom. Others, however, suggest something even more profound, that changing the past doesn't destroy your own timeline. It simply creates a new one, a branch reality, where your actions form an alternate universe while your original timeline remains untouched. This is the multiverse paradox solution, blending relativity with quantum theory. In this view, every paradox is resolved, not by stopping you, but by splitting reality. You kill your grandfather in one world, and remain alive in another. The cause and effect are preserved, but across dimensions. Still, one question haunts scientists and philosophers alike. If time travel creates infinite realities, where does the traveler belong? Would they remain tied to their original timeline, or drift between the echoes they've created? And if every choice births a new universe, could our entire existence be the ripple effect of some traveler's forgotten decision? Some physicists quietly speculate that paradoxes may be the reason we've never met time travelers, not because they don't exist, but because their timelines can never intersect with ours like ships on separate oceans. We may drift forever beside their reality, never seeing the wake they leave behind, yet the human mind cannot resist temptation. Every time a paradox closes a door, imagination opens another, and so modern physics has turned to the next question, not whether paradoxes forbid time travel, but whether the universe itself might already be correcting them silently through the mysterious dance of probability. If the universe is protecting itself from contradiction, then perhaps every impossible event we dream of, every moment that shouldn't happen, is simply part of a larger equation that must. In that case, maybe the paradox isn't the problem. Maybe it's the proof that we're getting close. For centuries, time travel lived in the realm of dreams, a fantasy of storytellers, philosophers, and visionaries. But in the 20th century, something changed. Equations that once seemed abstract began to whisper real possibilities. Einstein's relativity had already shown that time could slow down under gravity or speed. The next question was inevitable. Could it ever reverse? The race to find out began. In the laboratories of the world's most brilliant minds, time became an experiment, Hermann Minkowski's space-time geometry evolved into Kurt Gödel's rotating universe, a solution to Einstein's equations where time loops upon itself. Gödel's cosmos was strange, a universe spinning so fast that a traveler moving in the right direction could, in theory, return to their own past. It was elegant, logical, and terrifying. Einstein himself was unsettled by it, not because it was wrong, but because it was too right. Later, Frank Tipler proposed the Tipler cylinder, an enormous rotating tube, infinitely long, twisting space-time into spirals of closed time paths. If such an object could exist, rotating near the speed of light, it might pull reality into a loop, allowing time to circle back upon itself. But there was a catch. It would require more energy than the universe could provide. And yet, the math remained flawless. Then came Kip Thorne, one of the greatest physicists of our age, the mind who turned theory into the film Interstellar. Thorne explored the possibility of traversable wormholes, bridges through space-time stabilized by negative energy. He found that the laws of relativity do not forbid time travel. They merely make it extraordinarily difficult. Impossible? He asked. No, merely improbable. Meanwhile, experiments on Earth quietly began to brush against the edges of time. Atomic clocks placed in airplanes tick slower than those left on the ground, proof that motion warps. Time, particles accelerated near light speed live. Longer than they should, their internal clocks stretched by. Relativity, and high above our planet. Satellites in orbit run faster than time on Earth, forcing engineers to constantly correct GPS signals. Without that correction, your phone's map would be off by miles every minute, every second. Every coordinate you use to find your way home is a silent confirmation that time is not absolute. In labs, scientists have even managed to entangle particles across time, influencing one state before its partner has even existed. It's small, microscopic but undeniable, and somewhere, buried in the equations, the boundary between the present and the past grows thinner. The world begins to realize the first time travelers may not arrive in machines of steel and light, but in data, particles, or consciousness itself. Because to move through time, one does not need to move their body, only their information. Information is indestructible. It cannot be erased from the universe. It can only transform, reappear, or rearrange. And if information can survive the death of a star, could it also survive the death of a moment? Could the essence of memory or thought travel backward or forward across space-time? Some researchers now suspect that the first travelers have already moved, not through physical time, but through the quantum field that underlies it. Experiments in quantum retrocausality suggest that a choice made in the present can influence results measured in the past. It seems absurd. Until it works, the impossible is no longer myth. It is physics, waiting for courage, funding, and a mind daring enough to open the door. And when that door opens, humanity will not simply explore the universe, we will explore time itself. Somewhere in the vast corridors of history, small irregularities whisper like static in the grand signal of time, strange faces in ancient paintings, objects out of their century, people who appear and vanish, leaving no trace except stories that defy logic. To the skeptical mind, they are myths. To the curious, they are footprints. But what if, just what if, these irregularities are echoes? Echoes of visitors who slipped through the veil of time? The photograph of a man in modern sunglasses at a 1940s bridge opening. A Swiss watch found sealed inside a 400-year-old Chinese tomb. A woman in 1928 footage seemingly speaking on a cell phone. For decades, each artifact, each anomaly, has been dismissed as coincidence, misinterpretation, or fraud. Yet they all share one thing, a temporal mismatch, a dissonance between object and era. And where there is dissonance, there is possibility. Historians call them anachronisms. Physicists call them temporal inconsistencies. But what if they are not errors of history, but messages from it? Some theories suggest that time travelers, if they exist, could never truly rewrite the timeline. Instead, their actions ripple subtly, like a whisper in a hurricane, altering only details too small to be noticed. In quantum terms, they would shift probability, not events. A butterfly lands on a different leaf. A note is written instead of spoken. And somewhere, an invention appears years too soon. Consider Nikola Tesla, who once described receiving signals from another world and designing a machine to see through time. Or Leonardo da Vinci, sketching flying machines centuries before aerodynamics existed, visionaries. Or visitors remembering fragments of a future they once lived. Even Einstein hinted that the distinction between past, present, and future is only a stubbornly persistent illusion. And so, the illusion continues. In our digital age, stories surface almost weekly. Travelers from the year 2700 posting cryptic videos, warning of coming disasters. Many are hoaxes. Some are performances, but among them, a few display knowledge uncannily precise. Events predicted with eerie accuracy. Photographs altered at the atomic level. Metadata that defies timeline logic. Are these the work of chance, or the result of a civilization that has already mastered temporal movement, but hides its existence behind the noise of disbelief? Theoretical physicist Dr. Ronald Mallet once said, "If time travel is ever achieved, its effects may already be here. We just don't recognize them yet." Imagine that somewhere right now a traveler stands in this century, unseen, blending among us. Maybe they're not here to change history. Maybe they're only observing, studying the origins of their future, or perhaps trying to prevent it. Because if time can be traveled, it can also be corrected. Every moment, every action, every decision could become a thread in an ever-adjusting tapestry. And if one thread falters, the travelers return to repair it, leaving behind only fleeting distortions. Déjà vu, forgotten dreams, flickers of memory that don't belong. These could be nothing more than tricks of the mind. Or they could be signs of temporal maintenance, a universe continually edited by its own future. Perhaps we are not waiting for time travelers to arrive. Perhaps they're already here, walking among us, watching, recording, and quietly ensuring that time unfolds exactly as it must. And if you've ever felt that something in your life has changed, but no one else remembers, maybe, just maybe, you have already met the echo of tomorrow. In the vast machinery of the cosmos, every cause has its effect. Every spark leads to a flame, and every flame casts a shadow. But what happens when the shadow reaches back and touches the spark that created it? That is the essence of the time paradox. Imagine traveling back to the past to meet your grandfather before he has children. And in that meeting, you accidentally prevent your own birth. Then who was it that traveled back in the first place? This is the grandfather paradox, the most haunting puzzle in all of temporal science. It is a question with no answer, because every answer destroys itself. Scientists have wrestled with this for decades. Stephen Hawking proposed the chronology protection conjecture, suggesting that the laws of physics conspire to prevent time travel on all but subatomic scales. In other words, time protects itself. Any event that would create a contradiction, a loop where a cause erases its own effect, simply cannot happen. The universe will twist, warp, or rewrite the sequence to preserve consistency. But there's another possibility, one even stranger, that paradoxes don't destroy reality. They multiply it. In the many worlds interpretation, Every choice splits reality into new branches. If you travel back and prevent your own birth, you don't erase yourself. You simply move into a timeline where you were never born. The original version of you still exists in another strand of the multiverse. Cause and effect remain safe, not in one world, but in infinite ones. But if every timeline can exist, then every paradox can too. In one reality, you may save the world. In another, you may destroy it. This idea changes everything. It means that time travel might not be about moving through one continuous stream, but about shifting from one timeline to another, a quantum migration through the multiverse. Yet even this theory faces resistance. Some physicists argue that the multiverse itself could collapse under the weight of infinite contradictions, like mirrors, reflecting mirrors until the image fades into static. And there are hints that nature already enforces a kind of temporal logic filter. Quantum experiments show that particles influenced by future measurements still preserve global consistency. The message seems clear. You can bend time, but you cannot break it. Perhaps time is not a river to swim backward in, but a living organism, self-healing, self-correcting, and self-aware. If so, then every attempt to rewrite the past is met with an invisible resistance, a hand, unseen, guiding events back toward equilibrium, that moment when you narrowly avoid an accident, when plans mysteriously fall apart only to lead you somewhere better. Could it be coincidence? Or the universe quietly repairing a temporal tear before it grows too large? And if time can heal itself, does that mean it can also learn? Every loop, every traveler, every experiment could be teaching the cosmos something new, a feedback loop of evolution, not in biology, but in causality itself. So perhaps paradoxes are not problems to be solved, but messages from time, reminding us that existence is already perfect in its design, and to change the past may not destroy reality. It may simply create another. In the end, one truth emerges from every theory, every equation, every paradox. Time is not our enemy. Time is our mirror, and when we finally look into it deeply enough, we may not find the future or the past, but ourselves staring back. What if the secret of time travel is not buried in equations or engines, but in consciousness itself? What if the traveler is not a machine, but the mind that dares to awaken? For centuries, science and spirituality have walked separate paths, each seeking to understand the nature of existence. Yet as we venture deeper into physics, past quarks, past quantum foam, past the Planck horizon, the boundary between matter and meaning begins to dissolve. Modern physics now admits time may not be a fundamental property of the universe. It may be an emergent illusion, a byproduct of consciousness observing change. Without the observer, without awareness, does time even move at all? The ancient mystics once said, "All moments exist at once. Only perception creates the sequence." And in laboratories today, quantum experiments echo the same wisdom. In the double-slit experiment, particles behave as waves of probability until they are observed. The moment awareness enters, the wave collapses into reality. It is as if consciousness writes time, one observation at a time. Now, imagine, what if consciousness could step outside the flow it creates? If the observer could detach from linear perception, could they not see the entire timeline, past, present, and future, as a single luminous whole? The equation suggests it. Deep within quantum cosmology, there are models where time has no beginning, no end, where the universe is a static, eternal structure, and movement through it is merely the act of attention shifting across coordinates. In such a reality, time travel is not motion, it is reconnection. Some researchers, like Julian Barber, argue that time is nothing more than change without clocks, that each moment, each configuration of the universe is complete in itself and consciousness. By remembering the previous one creates the illusion of continuity. If this is true, then the traveler who transcends memory itself transcends time. Mystics have called this enlightenment. Scientists call it non-local awareness, two languages describing the same horizon, the last horizon where science meets the infinite. Beyond that horizon lies a realm where time folds into stillness, a reality not measured in seconds or centuries, but in presence. And there, in the silence beyond causality, the traveler no longer moves through time. Time moves through them. Perhaps the ultimate truth of time travel is not escape, but understanding, not to change the past, but to realize that all pasts, all futures, already coexist within us, in dreams, in memories. In déjà vu, fragments of other timelines flicker like sparks in the dark. We are not observers of time. We are its creators. Every thought becomes a ripple in tomorrow, every choice a thread woven into eternity. And when humanity finally steps beyond its limits, beyond the machines, beyond the paradoxes, it will discover that the key to the universe was never out there. It was within. The traveler is not a visitor from the future. The traveler is us. We are the witnesses, the storytellers, the echoes of countless tomorrows, all converging here in this one infinite moment. And maybe when the last star fades and the universe grows silent, time itself will remember this, the brief spark of consciousness that dared to ask, what if tomorrow has already happened? And we are the ones who made it real? There is a moment of Woledger just before dawn, was when the world stands still, shadows stretch, the air holds its breath, and for an instant, time forgets to move. In that fragile silence, one might hear the faintest whisper, an echo, not from the past, but from tomorrow. For centuries, we have chased that whisper across stars through equations. Inside the human soul, we built clocks to measure time, telescopes to see it, and machines to bend it. Yet, in the end, the truth was never out there. It was within the heartbeat of the observer, in the pulse of awareness that turns chaos into creation. The story of time travel is not about escaping our reality. It is about understanding it, realizing that every second we live is already an act of traveling. When you remember, you visit the past. When you dream, you glimpse the future. And when you choose, truly choose, you alter the shape of eternity. Every human life becomes a timeline, every thought a bridge across dimensions. The physicists may speak of wormholes, the mystics of awakening, but both are reaching toward the same horizon, a point where the traveler and time become one. Perhaps someday humanity will build the machine that crosses centuries, but long before that, we will awaken the traveler within. Because the real-time machine is not made of steel. It is made of memory, imagination, and wonder. And every time a child looks at the stars and asks, what if? The future begins again. Time, it seems, is not a line, but a song we have been singing since the first moment of awareness, and will continue to sing long after the last atom fades. And so, as we close this journey, remember, you are not bound by the past. You are not waiting for the future. You are the intersection of both, the echo of everything that was, and the architect of everything that will be. In this vast eternal universe, you are the traveler, and your journey has only just begun.